Hello everyone, welcome to the second video of arithmetic progressions. So in this video we'll be learning about introduction to arithmetic progressions, basically what arithmetic progression is and how to identify whether a given equation is or the given progression is an arithmetic progression that we'll be seeing in this video. So let me start the video. See, arithmetic progression. Now in the previous video I have told you what is the definition of a progression. The progression means that any sequence in which you can write a general formula for a specific nth term, then it will be called a progression. Arithmetic progression means, I will first of all give you the definition. A sequence is said to be arithmetic progressions, which is abbreviated as AP, if the difference of the term and the previous term is always the same. If the difference of any term and its previous term is always the same, then it will be called an arithmetic progressions, which I will abbreviate as AP in the coming set of videos. A sequence is said to be an arithmetic progression if the difference of any term and its previous term is always the same. So let me give you some examples which will make this arithmetic progression more clear. Say I have a sequence 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So the sequence starts with 1 and ends at 10. So will this be an arithmetic progression? Let us see whether it is or not. Let me subtract 1 from 2. What will I have? 1. 3 minus 2, again 1, 4 minus 3, again 1, 5 minus 4, 1, 6 minus 5, 1, 1 and so on. You take any two consecutive numbers and subtract them, you will get the difference as 1, which will remain constant. And as per the definition of an arithmetic progression, it is said that the difference of any term and its previous term should remain constant. Hence this is an AP, which is nothing but a set of natural numbers. Now I have written this up to 10 only. You can write it up to 100, up to 10,000, up to 1 lakh, up to 1 crore, up to whatever number you want. So this will be an AP. Let us take another example. Say I have 2, 4, 6, 8, 10, 12, 14 and so on. Now let us see the difference. 4 minus 2, 2. 6 minus 4, 2. 8 minus 6, 2. 10 minus 8, 2. You take any two consecutive terms, the difference will always remain the same. Hence, this is also an AP. So I think the definition is making a bit of sense now, correct? So let me take one more example. Say, let us take the set of multiples of 5. 5, 10, 15, 20, 25, 30, 35, 40 and so on. Is this an arithmetic progression? Yes, it is. 25 minus 20, let us take any two random terms. 25 minus 20 is 5, 30 minus 25 again 5, 40 minus 35 again 5, 10 minus 5 again 5. Hence you take any two consecutive terms, the difference is constant, hence this will be an AP. So now there are few notations that I would like to tell you that in general every book uses, that the first term of an AP is represented as small a. In general, the first term of any AP is represented as small a. And the common difference, this 5 in this case, this 2 in this case, is called the common difference. The difference between any two consecutive terms which is constant is known as common difference. And this is written as D, small d. So if I would like to write a general arithmetic progression using A and D, how can I write it? I'll write it as first term a, second term will be a plus my common difference, so it becomes a plus t, third term a plus 2 times t, fourth term a plus 3 times t, a plus 4 times t, and it will go on like this. Okay, let me relate this with some example which will make this concept more clear. Let me take the last example for you. I had 5, 10, 15, 20, 25, and so on. Okay, in this case my first term a is 5. Okay, and if I want to know the common difference, I will take any two consecutive terms, subtract them to get the common difference. In this case, if I'll subtract 15 minus 10, I'll get 5. So common difference is 5. And always note that, always remember for the case of arithmetic progression, that you subtract the first term from the next term. Okay, don't do the reverse. If you are taking these two terms, okay, this should be subtracted from this. Okay, or if you're taking these two terms, this should be subtracted from this. Like it is, say, if a1, a2, a3, a4, a5, a6, if this is an AP, then you will get the common difference by subtracting a2 minus a1. Okay, d will not be equal to a1 minus a2. Okay, always remember that. This is a very common mistake that generally students make. Okay, but never ever do that. Similarly, d you can also get by, let us take these two terms, so e5 minus a4 or a6 minus a5. This should be greater than this. Okay, so day is 5. Now if I want to write the same series, I can write it as 5, my first term. Second term will be 5 plus 1 into d, that is 5 plus 5, which becomes 10. Second term will be 5 plus 2 times my common difference, that is 5 plus 10, which will give me 15. Am I getting the same series? Yes. Next term will be 5 plus 3 times 5, which will give me 20, and so on. Okay, so this is how I will write a general arithmetic progression. Now you know that arithmetic progression can be of two types. Okay, what can be those two types? One is finite AP, okay, and second is infinite AP. Okay, the difference, you know, finite AP will have finite number of terms, and infinite will be, AP will have infinite number of terms. Okay, that is the small difference. Second point that you should note that this common difference d, that can be either positive or negative. It can be a fraction, it can be a decimal. Okay, it can be anything. Okay, the only constraint is that it should be common for any two terms of the AP. That's the only thing. Okay, say for example, if I'll take 0.2, 0.4, 0.6, 0.8, this is an AP where a is equal to 0.2 and d is equal to, say, 0.4 minus 0.2, which is equal to 0.2 itself. Okay, or let me take another example. If I'll take, say, 0.36, 0.46, 0.56, 0.66, 0.76, and so on, this is also an AP. Okay, with a equals to 0.36 and d is equal to 0.46 minus 0.36, that is 0.10. Okay, hence now I think that you can identify any given AP, and then you can then see and apply the properties of the AP that we'll be seeing in the next set of videos. Okay, so I hope you like the video, your concepts are clear. Okay, and please like the video, please share it, and do subscribe our channel for more updates regarding the videos. Have a nice day. Thank you.